I'm Rob Morell, Director of Product Development with Ebullient. I'm here with Carl Rosenberger, Director of Product Development at RAVE Computer, and we're really excited to kind of talk about the CIPHER R20 a little bit here. We worked together to kind of come up with this first in its class, I think, liquid-cooled Tesla-based workstation, and I'm really excited with what we were able to develop. It's completely awesome, and I think people are really going to enjoy it.
Yeah, it's funny, they said it couldn't be done, but here it is. And the two-phase liquid cooling is just amazing.
Yeah.
With the GPU boost running full-time, we get a 55% additional performance out of the machine that we wouldn't get on air cooling.
Yeah, it's almost like we're getting a free K80's worth of performance with if we were to be air cooling it. Yeah, and so I mean, the benefits of this are really many. The added performance that you're talking about, it runs incredibly cool, so I think less concern about any reliability issues with the CPUs or GPUs, and it's incredibly quiet. I mean, we can barely hear this thing run, and we're standing right next to it.
Yeah.
So what are kind of common applications that these machines would be used for?
Well, a lot of people are asking for these machines when they want to do containment of their IP or their information. They want to do work in their physical location, so they don't send it off over the network to a cluster or something. And there's several reasons for that. One is there's a queue on the cluster and you have to wait every time. And if you have to iterate your code, make changes, and iterate, that can be pretty time consuming and costly.
Yeah.
And another reason is your information can stay within your physical boundaries if you have one of these machines. So for defense or intelligence, it's a very good solution.
Don't have to worry about something leaking out there that shouldn't be.
Right.
Very cool. So here in this demo we have, you can kind of see the two-phase technology here, the phase change cooling. There's quite a bit of bubbling going on there. So the way that this works is we take an engineered fluid from 3M, as you know. It's Novec 7000. It's a dielectric fluid, which means it doesn't conduct electricity. So it's completely safe to electronics. Something happens in shipping where something gets knocked loose and there's a leak. Unlike water, where you'd have to worry about replacing a couple of $4,000 GPUs, just give us a call and we can take care of it, no problem. And then unlike water, we actually don't do sensible cooling, or I guess the water is sensibly heated. It gets warmer as it goes from device to device. Since we're going through a phase change, once that phase change is initiated, temperatures remain very consistent from device to device. So we've got some performance data going on the back here, and we've got a lot of the radiator area blocked with different signage and things like that, but we're within 5 degrees C from GPU to GPU, which I think is pretty phenomenal.
Yeah, and you're running in the 50s and 60s C.
Right.
These GPUs don't throttle until 88 C.
Right.
They'll shut down from a thermal overload at 92.
Right.
So keeping them in the 50 to 60 degree range means that not only can they run indefinitely with no damage from heat, the GPU boost can kick in and they run at a higher clock frequency.
Right.
So you normally run a K80 at 562 megahertz.
Yeah.
In GPU boost, they're running 875.
That's pretty big.
That's a significant boost.
Pretty big step up. Yeah, I was really surprised with how difficult it was to keep the K80 cool, because with those two GPUs in line, you're with air, which is how it was designed initially from the manufacturer. That air gets a lot warmer going from the first GPU to the second GPU, so they end up throttling pretty easily from what I think we saw in our initial kind of baseline testing. So, Rob and Carl again here. We're talking now over at the RAVE booth. It's booth 3666, right? And we're here with the CIPHER R40, the big daddy. Why don't you tell us a little bit about this system?
Well, we call this one Juggernaut for good reason. It's got 4 K80 GPUs in it, 2 GPUs per card, so that's 8 GPUs. We have 2 22-core Xeon E5 processors hosting the system. We're dissipating 1,200 watts of heat of these 4 cards and another 300 off of the 2 processors, so 1,500 watts of heat total just in those components. And you really can't tell that it's nearly silent in this environment, but it is.
Yeah.
And we don't have a lot of fans blowing high velocity, making a lot of noise in here. So this is excellent for some pretty heavy duty crunching, GPU crunching, but you can do it in a quiet environment. We have some to universities where the professors want to do work in their office while they have meetings, but they need some serious power.
Yeah.
So.
Yeah, I mean, with everybody else that's kind of talking around, it's not too populated over here, but just over normal kind of conversations, I can't even hear this thing run either.
Yeah,
so pretty impressive stuff. And then so as far as like storage options on this, if people wanted to have on machine storage, what are the possibilities here?
Well, we run off SSD typically, but if you wanted to use spinning disk, you could do 24 terabyte pretty easily, just in an internal. We have room for 4 more bays in the front where we put
hot
2.5s.
swap.
Hot swaps. So you can put 1 terabyte SSDs in the front, have 4 of those. We can do RAID if you like. And then your massive storage would be spinning disks down in the guts of the machine.
Yeah, and then just like the CIPHER R20, if you wanted to do a quadro card, you'd be able to put that in here as well, right?
Correct.
So a pretty flexible system, can kind of tailor it to whatever the customer is looking for.
Yes.
We're looking at the CIPHER R10 here. It's a small package, but a pretty heavy hitter.
Yeah.
You want to kind of talk us through this system?
Well, we wanted a system that not only was powerful but small, could be transported between office and home, or from an office to another office. You can take this on the plane with you. It's got a 22-core Xeon E5 processor in it. It's got and a K80 card. Because of the small form factor, we only put 1 K80 card in here, but that's a 300-watt card in a little tiny form factor like this that's nearly silent.
Right.
So this is one heck of a little tiny whopping powerhouse.
Yeah.
As you can see on the screen here, we've got 100% utilization because we're doing folding at home. That's loading the GPUs and the CPU. We're in the 60s for temperature, which keeps us in GPU boost 100% of the time. Again, another 55% additional performance. And that's you can see right here, we're at 300 watts just with that K80 card.
Right. Yep.
As far as the turbo boost goes, the base frequency is 562 megahertz, but we're running at 875.
Yeah.
And we've been doing this for hours.
Right. Right. Whole show, pretty much.
Yeah.
So this is.
We're also loading the CPU, as you can see.
Yeah, a lot of utilization on the CPU. So this is 450 watts of power that we're dissipating through this system. I mean, you look at this thing, it's not that much bigger than a sheet of paper. So it's incredibly small. You could have this on your desk pretty much right next to you and you know, be very comfortable. So yeah, I think this is one of my favorites just because it's so small and it so clearly shows the benefits of liquid cooling, you know, especially the Ebullient cooling system.
What you've done in this box is nothing short of remarkable.
Yeah.
It's absolutely amazing.
Thanks. Well, it's been a lot of fun working with you to jointly develop this CIPHER line, and we're really excited about sharing it with everybody else.
Thanks, Rob.
Yep, thank you.